So we're going to talk now about contrasting Java IO streams with Java streams. And at first glance, they may seem similar because they both have the word streams in them. But it turns out in practice that a Java IO stream and a Java stream are really not related directly, although they can often be used together in interesting ways, which we'll talk about as well. And in fact, I'll show you an example program that demonstrates how you can combine Java IO streams with Java streams to get the best of both streams worlds. So what is a Java IO stream? A Java IO stream represents an input source or an output destination. So for example, a program can use an input stream to read data from some source, one item or one element or one character or byte at a time. And a program could also use an output stream to write data to a destination, one item, one element, one character, one byte at a time. And I'm sure you've all done something along these lines at some point if you've programmed in Java or other languages for that matter. A stream itself can represent different sources and different destinations. You can have sources be disk files. You can have various devices like network interfaces. You can have other programs communicate. You can store data in memory. And the same thing holds true for memory for the destination as well. So you can read and write from different sources and two different destinations. Streams, IO streams supports many different types of data. So you can have simple bytes, a byte stream. You can have primitive data types like integers and longs and doubles and so on. You can have characters in various locale formats. You can read and write objects. And there's a whole slew of different classes that help to coordinate and interact with the IO streams abstractions. Some IO streams simply pass data on, whereas others can be used to manipulate or transform the data in various ways. But the transformation is typically fairly simple and fairly localized. There's a nice article that appears at the bottom of the slide here, the link at the bottom of the slide, that talks about how the Java IO streams framework implements the Gang of Four decorator pattern, which is a pattern that's used to provide a way of encapsulating or decorating some object with other types of objects called decorators. And they can do other things to data that is passed back and forth to the kind of the host or the original object, the base object, if you will. So you might want to take a look at that article for a nice discussion about the decorator pattern and how it relates to Java IO streams. Now, key point, Java IO streams are different from Java streams, which is the focus of our course. IO streams, as we've seen, are for reading content from a source or writing content to a destination. In contrast, Java streams enable programs to manipulate a collection of data in a declarative way. And so using functional style operations, things like map or filter or flat map or sorted and so on. So the real focus with a Java stream is on transforming or filtering data as it flows through the stream, whereas the purpose of an IO stream is to read or write content from a reading from a source and writing to a destination. Now, the good news, of course, is you can combine IO streams and Java streams together to make all kinds of interesting applications. And so that's what we're going to talk about now. So modern Java, which means Java 8 and beyond, integrates Java streams and Java IO streams together very nicely. And if you take a look at this particular article that I have cut and pasted some pictures from and provided a link to at the bottom of the slide, it talks about various ways in which streams have been integrated into Java classes, like the files class or the buffered reader class, and so on. And there are ways to read lines one at a time. You can read all the lines. You can have buffered readers have lines. And these are all ways of converting underlying Java IO streams into Java streams that you can then manipulate and work on in a declarative and functional way. And to illustrate that point, we're going to go take a look at an example that you can find in my GitHub repository here at the link at the bottom of the slide. And this program demonstrates how to use modern Java IO streams and Java streams to build a cosine vector map from a comma-separated value file that contains values of movie cosine encodings. So let's go ahead and take a look at that now. So here we are in my IntelliJ project for the EX40 example in my GitHub repository. And as I said before, this example shows how to use modern Java features to build a cosine vector map from a comma-separated value file that contains cosine values for movies. And this is what we use for things like a recommendation engine. We have another course where we teach recommendation engines where you look for values that are similar. And this is basically building the input for that. So here's the main program. We go ahead and call a method called vector map, and we'll take a look and see what that does. You can see here that vector map goes ahead and opens up a resources file, which is over here. It's a very large file, so I'll let it load for a second. And this contains all the information about the movies, all the encoded information, things like the director, the cast, the genre, the language, all that kinds of information is encoded in vector form. And so we go ahead and open that up from the resources folder, and then we get the file for that. And that's going to call a method called load CSV file. So let's go take a look at load CSV file. And I think the data set should be loaded now. So you can see here that we have the file contents, which says the title followed by the vector descriptors. And so here's a title like Avatar or Pirates of the Caribbean or Spider-Man 3 and so on. And then encodings of information about that particular type of movie in a format that can be processed electronically. We're not going to focus on the recommendation engine, just the I/O part, getting the data in. And you'll see what we do. Load CSV file takes in a path on the file system, which in this case is the path name for that data set. And it goes ahead and it basically converts that path, which is a string, into a paths object, and it passes it to the files lines method. And file lines will read that file and then using Java I/O streams, and will then convert it into a stream, in this case of strings. So we're going to have a stream of strings, which we call lines. And notice how we use the try with resources feature in order to ensure that, that the stream cleanup is automatically done when the try with resources block exits. And that's some magic that was added to later versions of Java to do that. So what we then do is we take this stream and we skip over the first item, because the first item was just the thing that said original title followed by vector descriptors. So we skip that. And then we go ahead and we divide the title from the cosine vector. And that's separated here, as you can see, by a semicolon. So we use a stream, we use a Java string operation to split this particular string into a stream of strings in an array. So we have a stream of string arrays. And then we go ahead and pass that to the map operation. And that's going to make a simple entry, which is just a tuple with basically a key and a value. And we're going to put the name of the movie as the first entry. And then we're going to call a method called parse vector, which is going to take care of everything that comes after that. And we'll look at that in a second. And that's going to create a stream of simple entries with the movie title followed by the list of all the cosine mapping values, or the values that represent the movie encoded. And then what we're going to do, we'll look at parse vector in a second. We're then going to collect everything up into a map, which will have a map of the keys to the values, merging the entries together. And that's what gets returned from this, is a map that maps the movie titles to the descriptors of each movie. Just for kicks, let's go take a quick look at parse vector. This is a pretty neat thing. It takes in a string containing the values that encode the movie for our machine learning algorithm, which ends up doing a cosine similarity index sorting. That's outside the scope of this talk. And then we use a regular expression pattern to compile a splitter that will split the contents here by spaces. As you can see here, each of these values is separated by a space. And then we're going to call the split as stream method. And we're going to pass to it a string that's going to remove the leading brackets and the leading space. You can see we have a bracket followed by a space, and then the trailing bracket. And so that's how we strip off just the part that contains the values we care about. And we're going to run this whole stream in parallel because could be a lot of elements to deal with. And we're going to convert each value from a string to a double. So we have a bunch of doubles. So we're going to have a stream of doubles. And then we end up collecting that stream of doubles into a list of doubles. And that's what gets returned from the parse vector method. And you can see here, if we go back there, parse vector then returns that as a list of doubles. So this is just a simple example that demonstrates how you can combine together Java IO streams, which know how to open the file, know how to read in the contents, and then use the lines method that we saw down here, the one that's there, in order to convert that IO stream into a Java stream, which we can then process and parse in various interesting ways. So this is the end of that example, just to kind of show you how you can combine Java IO streams with Java streams.